An electrochromic material is a material that will undergo a change in color or opacity upon the application of a voltage. The voltage will change the structure of the material and therefore its reflectance or transmittance. An electrochromic material can be placed inside an electrochromic device, or an ECD, to modulate its optical properties. An electrochromic device consists of 5 components: an electrode, the electrochromic material, an electrolyte, an ion storage layer, and another electrode. This can either be superimposed onto a substrate or sandwiched between 2 substrates. The electrodes are used to conduct electrons. The electrochromic layer is the layer that will change its optical properties. The electrolyte allows passage of ions between the ion storage layer and the electrochromic material. It can either be a liquid, gel, or a solid. The ion storage layer can store ions, which may or may not change its optical properties. All electrochromic devices work in a similar way. Therefore, the electrochromic device containing tungsten oxide as the electrochromic material, lithium perchlorate as the electrolyte, and nickel oxide as the ion storage layer will be used to illustrate the mechanism. The applied voltage will cause electrons to move through the electrode into the electrochromic material. Lithium ions will be attracted to the electrochromic material via electrostatic interactions. The tungsten oxide, lithium ions, and electrons undergo a reduction reaction to create lithium tungsten oxide. This changes the color of the electrochromic device from the bleach state, colorless, to a blue color. Meanwhile, the lithium atoms stored in the ion storage layer undergo an oxidation reaction, which will convert lithium nickel oxide into nickel oxide. The lithium ions enter the electrolyte to regenerate the lithium ions lost. The electrons flow back to the cell to complete the circuit. If the voltage is reversed, the reverse process happens. Electrons flow to the nickel oxide layer. Lithium ions enter and react to form lithium nickel oxide. Lithium tungsten oxide reacts to form lithium ions, tungsten oxide, and electrons. The lithium ions re-enter the electrolyte. Electrons flow back to complete the circuit. This technology can be used for various applications, such as in smart windows, sunglasses, or mirrors in the automotive industry.